Good evening, everyone, and thank you for coming out to the Rubin Museum. I'm Tim McHenry. I direct programs here. And this is where, if you haven't been here before, where we take inspiration from the wisdom traditions of the Himalayas and bring them to you here in the foothills of Chelsea. And wisdom traditions, well, yes, that's what we're exploring this whole season, the whole nature of what wisdom actually is. Is it knowledge? Is it insight? Is it understanding? This is what we're exploring. And so we've drawn people from different areas together to have on-stage conversations and find out what is wisdom for them. And a few of them, Alana Glazer is going to be here on Monday to talk about intuition with psychologist David Ludden. Ellen Burstyn, the actress, is joining. Isabel Benke Izquierdo to talk about animal wisdom. Isabel studies the bonobos in the Congo and looking at their relationships and how they mirror some of ours. And probably not those that might be reflected on television a little later tonight, but nonetheless, we'll move on from that. And then Krista Tippett and Elizabeth Less will be here in December. I mean, there's all sorts of things going on, so I hope you can join us on various stations of our particular journey. So one aspect of knowledge that we want to address tonight is that of genius. Where does it spring from? What is the understanding that makes it go beyond common understanding and knowledge that we possess as a society? And what better an example to choose than Einstein? And David Bodanis has just come out with a new book, a biography, but he entitles it Einstein's Greatest Mistake. And if you can't imagine what that was, you will find out tonight. But it's interesting what he writes about the nature of genius, and I'll just pause to read you a short paragraph. Geniuses have to push hard to come up with their first ideas. Almost always they're going far past what everyone assumes to be true and have to be confident that they are right. That involves being stubborn. But they also need to be supple, making sure their breakthroughs incorporate all the relevant factual information, then keeping their later work responsive to what others are finding out. The trick is to surf this line between the supple and the stubborn without straying too far either side. Does Einstein do it in any part of his life? Well, we're here to find out. David Bodanis, of course, is no stranger to bestsellers. His book, The Secret House, from 1986, was on the New York Times bestseller list. And E equals MC squared, you've heard that equation before, was the title of a book of his which got translated in no fewer than 28 languages, and wait for it, also became a ballet presented by the Sadler's Wells in London. He's going to be joined on stage by another David Auburn, who most potently for this particular conversation brought out a mind-blowing, quite literally, play called Proof, which won the Pulitzer and the Tony in its time, and really questioned the nature of genius from a very different angle. So we're delighted to bring these two Davids together for you to hear and then address questions to a little later on, and then maybe join and sign a book afterwards, because this is a book launch and a celebration of David Bodanis' latest book. So please welcome David Auburn and David Bodanis.
Hi, man.
Hello.
Hey.
Hi. Thank you very much. This is exciting, and David and I have never met, but I think we'll find a few things to talk about. And I read the book over the last couple of days, and it's a wonderful book. You cast a very wide net. It's about Einstein, but it's also about many other things, and you do everything with such a wonderful lightness of touch. I thought we could talk about the title maybe to begin with. I mean, I don't know if we want to give it away, sort of spoiler style, as to what Einstein's greatest mistake was. When I started reading the book, I thought I knew what it was. I thought it was about his use of the cosmological constant, which he had famously said was his greatest mistake. It was a constant that he had added to one of his equations in order to account for what he thought was the static universe, if I've got that right. And years later, he regretted doing that. But that's not Einstein's greatest mistake, as it turns out. Do you want to talk a little bit about what is?
Yeah.
Yeah.
Where to begin? Einstein believed that the universe was like a book. If it's like a book, that means there's a writer of the book. It might be a deity. It might be impersonal forces that have always been there. If the universe was different, if the universe was like a magazine, you couldn't find a complete order. There'd be something like this, there'd be something like that. It wouldn't hang together. And in 1915, Einstein found a beautiful, simple equation, not equals mc squared, something even more beautiful that physicists think comes once in a century or maybe once in a millennium. It was a beautiful, simple equation, and it predicted that the universe was expanding. Well, in 1915, all scientists told Einstein that the experimental evidence is unambiguous. They thought the universe was just a bunch of stars in the Milky Way galaxy just floating in space. And beyond it, there was nothing. It was sort of like Donald Trump's brain. There was just empty space beyond. Well, Einstein had to modify and actually lacerate these beautiful, simple equations. And he never liked doing it. Imagine you have a beautiful sports car, a sleek Lamborghini or an old-style Porsche or something. And people say, no, that's not the right style, not that sleek design. You have to put anchors on it and bags of rocks attached. He just had to make his stuff ugly. So he did that, but he didn't like it. And then, but he had to do it because everybody said the universe was not expanding. 10 years later, the astronomers said, oi, they didn't say oi, but oi, we're sorry, we were wrong. All our experimental evidence was wrong. Indeed, the universe is expanding. Einstein said, I knew it. I knew it. I should have held my nerve. I really should have stuck to what I believed in, this beautiful vision that I felt I had been able to see, cutting through the veil of all the complexity around us to see the simple clarity behind it all, where everything was clean and pristine and exact. So he got rid of all those modifications, and he went back to his beautiful original equation. Now, many people think that those modifications were his greatest mistake, but they're the sort of mistake many physicists make in their life, and it doesn't destroy you. There was something that did destroy Einstein. It's the conclusion, the psychological conclusion he drew from that. He decided he'd been burned once. He'd listened to experimental evidence, even when in his heart, his intuition insisted that there was a clarity you could see behind everything. And if he had held his nerve, none of that would have happened. He would have been shown to have been right. He just had to wait 10 years. Well, around this time, in the mid and late 1920s, quantum mechanics was coming in. The book goes into it a bit more detail. It's the study of things on the ultra-small level. There's electrons or smaller than that. And it suggests that on the tiniest level, everything's not smooth like an ocean wave, but foamy, inexact. There's probabilities and uncertainties, Heisenberg's famous uncertainty principle. The idea of quantum mechanics is you can't see an exact, precise truth. Well, when that came in, Einstein said, doesn't make sense. It doesn't fit my belief that the universe is a beautiful, clean book. I won't follow it. And people said, but the experimental evidence backs it up. He said, this I know. For 10 years, I left something beautiful to go along with experimental evidence. And that experimental evidence, it fluctuates. I'm not going to do it again. And that destroyed his life. For the next 30 years, his mind was at a superb level, but he was isolated. Physicists said, stay away from Einstein, ignore him, he's dangerous, he's wrong. Graduate students were told to ignore him. It was a horrible thing. He was famous in public. Movie stars liked to be filmed with him, Charlie Chaplin, all sorts of other people. He was interviewed all the time, but the connections he had had with other working physicists came to an end, and he was terribly sad.
You talk about how Niels Bohr, who was one of the godfathers of quantum mechanics, he had physicists from all over the world coming to study with him in Europe in the 30s and 40s. The same was not true of Einstein in Princeton, that he was a relatively isolated figure at that time, even though he was a very gregarious and very warm person.
Well, and that's what really hurt. Einstein used to say that there's two types of thinkers in the world. And you can imagine for yourself or your friends around you which category you go in. One sort are tennis players. Tennis players, if you have a problem, you come to work on Monday or you go home and meet your family and you think, there's a problem, we got to work it out. I want to find other people to talk to. Come on, let's huddle together and we'll work this out. Those are tennis players. Golfers are totally different. They come to work on Monday morning with a problem, or they meet their family and they say, look, I got a problem, Give me some space. I'm going to go to the coffee shop. I'm going to go for a walk. I need to work it out on my own. Tennis players or golfers. Einstein was a tennis player all through his life, and he loved it, just like Niels Bohr when he was older. Bright grad students, one or two people around him. He'd bounce ideas back. He would need some quiet time to do the final putting together, but he couldn't do it on his own, and he didn't like doing it on his own. He'd grown up in a warm, cuddly family and stuff. Well, after this thing happened with quantum mechanics, when he felt he was holding out for the truth, he felt he was just like holding up, like Atlas, holding up the correct heavens. The universe, of course, was like a simple, exact book. He was forced to be a golfer. He was forced in Princeton, New Jersey, a perfectly nice town. He never really liked Princeton. He felt the people there were a bit pretentious. He said it was a city of puny demigods standing upon stilts. So he didn't. It's much better now, I hasten to add. But it hurt his feelings. And it wasn't just a matter of age. Some people become stodgy when they're older. Some people don't. Einstein's mind was terrific. In his 50s, at one point in passing, he came up with the notion of that highly separated particles can sort of synchronize in a way, even at opposite ends of the universe. And that's the idea behind the new quantum computers that are being built as we speak, almost 80 years later. So he was a genius of the first order, even when he was older.
And lasers, you say, he came up with the early concept for what became lasers as well.
Isn't that incredible? He did his main work in astronomy, came to a head in the Berlin in 1915, in the winter, war-torn Berlin, World War I. And exactly as you said, David, the next year, while he was resting one weekend, he came up with the idea that led to lasers, which only could be built, human technology wasn't up to scratch, for another 40 or 50 years. That's how great he was.
So let's talk about him as a genius. And we should probably be good University of Chicago graduates and try to define genius. It must mean something other than someone who's really smart or someone who's really talented. Did you have a working definition of that when you were working on this book?
Yeah, I always thought that there's two things that separate genius from extremely good talent. A talented person does something you can do, and they do it better. If I were to run in a race with Usain Bolt, I would highly recommend that you do not vote on Mr. Bodanis to win. But I could imagine, I see, if I was stronger and had more fast twitch muscle and blah, 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 I could understand how he does it. I just can't do it. Genius is different. Genius is when people do things you have no idea how they got there. You're Neil Simon at his peak, or a great director, or music. Occasionally Mozart can be dull. But when Mozart's good, it's moving along, and then something comes in, it's almost like a joke. Where did it come from? It's brilliant, but it was unexpected, but yet it makes sense. So one part of genius is they do things we can't imagine how they do it. How the heck did they do that? Michael Jordan at his peak was able to be like that in athletic genius. The other thing about genius, think about the first part alone. If people just come in from unexpected angles, they can be kind of cranky or kooks. A genius is also correct. What they find is right.
Yeah. And I was struck in your book that you emphasized that Einstein wasn't necessarily a mathematical genius. He had talent, but math was not his strongest suit. He wasn't the best calculator. He wasn't technically, in some ways, as proficient as many of the people he worked with and relied on to do his work, but he had almost a visual imagination that allowed him to see things that no one else could see, and then he would work from those visual images backward to build and find the mathematics he needed to justify these images that he had in his head. Is that a good way to describe it?
That's exactly right. He had a vision. Here's a trick question. How could David and I walk parallel, making sure that we're walking parallel, and yet swerve together and hit? You would think it's impossible, but Einstein could visualize it in his head. We're walking parallel a few yards away from each other, and yet we swerve together and hit, and we always stay parallel. It seems impossible. Just think for a moment. How could that happen? Einstein solved it like this. Suppose David and I are on the equator, on the Earth, over here. We start walking parallel. We're walking due north. Hello, hello. We're walking parallel to each other, but on the curved surface of the Earth, we'd end up hitting at the North Pole, right? And we'd feel some ineluctable force pulling us together, even though you must be faking it, you must be getting it wrong. I'm walking due north. And you say, no, David, you're getting it wrong. I'm walking due north. Einstein could see that right away. And those waiting visions were really important. Another thing about the correct genius, rather than just a cranky person, is there's a truth that they're leading towards. Einstein once said that, this maybe ties in with wisdom, our themes. He said he felt like a little boy inside a huge library. And on the walls of the library, it was a dim room, and there were these various books. And the wall was filled with books. And these books had all the wisdom of the universe. It pre-existed, and it was there waiting. Normally, we couldn't see it. It was dark, it was dim, but very occasionally, the greatest members of our species could walk forward, take one of the books off the shelf, pull it down, open it, and they would see occasionally the waiting truths. They might see, one line might say E equals MC squared. Another might say, have the golden rule, or the Sermon on the Mount. And then we were forced, because of human fallibility, to close the book, put it back up on the shelf, and withdraw. Einstein believed in that vision. So even when he didn't succeed, before that winter of 1915, or when he was first putzing with the laser and other things, he knew that it was there waiting. That helped, not just, I wouldn't say drive him, it pulled him.
I loved in the book your descriptions of these intellectual tennis games he played, especially when he was mounting his strongest challenges to quantum mechanics. There's a conference in Brussels. I think it's 1928,
yeah.
Where you describe every morning Einstein getting up, walking to the conference with Bohr, and Einstein presents a new challenge in the form of a thought experiment to Bohr. He says, here's why I think quantum mechanics essentially couldn't be true. Because imagine there's a box, and see, he builds this very concrete image. And then Bohr wrestles with that all day and all night and comes back and explains to Einstein at the end of the day why he thinks that the thought experiment doesn't succeed in disproving quantum mechanics. And I love the idea of these two guys who were just sort of batting back and forth these very, very concrete images, and you almost playing a game with one another. The mathematics, the detail come later, but what they're working from is images that are so clear and so precise that we can even understand them, and non-mathematicians can understand them.
Totally. That was one of the things that made it, that I try to incorporate when I write a book like this. There's all sorts of equations, and there's some popular science books where people take a university textbook and they summarize it and they clarify it. And that's fine. That's a good thing to do. But here I tried to do something different. Suppose you didn't know what the content of that meeting was in Brussels. But what was going on was that two men had been friends. Niels Bohr, when he was young, met Einstein. They really loved and admired each other. Niels Bohr even gave Einstein some of his favorite Danish cheese, which for a man from Copenhagen is a special thing to do. It was terrible cheese. Niels Bohr loved really, really smelly things. And Einstein, out of love, pretended to enjoy it. So they got on well. And they really got on well because they were men who shared that vision about the waiting truths. They both, at least in Einstein's view, seemed to believe that the universe, there was a waiting book. And Einstein had found a man who he respected as a human being. Bohr was a very fine, noble man, the opposite of somebody like Heisenberg. He was a good human being. And they were sharing the same goal. Do you remember that beautiful line from Saint-Exupéry, the French poet? He said, love isn't looking together in each other's eyes. It's looking together in the same direction. And Niels Bohr and Einstein, for a while, were doing that. But then, when later quantum mechanics started coming in, one by one, people left Einstein's side. And they said, well, you talk about things being a book, you talk about God does not play dice with the universe, that everything's clear and exact. But the experimental evidence, time after time, is showing that there's foam on the surface of everything, like foam on a beautiful ocean swell. There's probability, there's uncertainty on the smallest level. I'm sorry, Einstein, we have to leave you. When I was young, I met a very old man in Paris. I was living in Paris, named, he was a French prince. His name was De Broglie. And he was one of the last people who had stayed close to Einstein. He was a brilliant man. He got the Nobel Prize himself. And he described what it was like at the Gare du Nord one time, coming back from a conference. Einstein was changing there, going on to Berlin. And Einstein said, well, you'll stay with me, right? And de Broglie, he didn't want to let down this man who was a mentor and kind and who he'd respected, but he just thought the experimental evidence is unambiguous. I might not like it, but I have to go there. One by one, everybody was leaving. And Bohr ended up being the leader of the quantum mechanics side. So at this great conference, it came to a head, and Bohr respected Einstein so much, he knew that if there was one exception, if Einstein could find one case where quantum mechanics didn't apply, then it would all be wrong, and indeed, Einstein would have been right. We're not going to go into the details of it, but very roughly, Heisenberg's uncertainty principle can be thought of as like this. Suppose I'm trying to measure what the air pressure is inside a tire, right? So I get a little gauge, and I stick it in the tire, and the air comes out, and it measures the pressure. But suppose we're having such a good conversation that as I do it, David comes by, and I stick the gauge in, the air starts hissing out, and I say, "What are you doing?" And I say, "Well, I'm measuring the air in the tire." And he said, "Well, you should look at it." I say, "Oh, I suppose I should." By the time I look at it, it might say 12 pounds per square inch. Well, when I first put it in, it was more. The air has come out, so it measures the wrong thing. So to do it accurately, I have to put it in and look really quickly. But if you think about it, the second I put it in and the air starts coming out, I get a figure, but the figure is slightly wrong. It's like if you open the refrigerator to see the temperature. Well, a little bit of cold air comes out, and the temperature is slightly different from what it was before. Heisenberg's uncertainty principle builds on that sort of observation. It says that if you're really, really careful, however careful you are, something's going to be a little bit lost as you interact with the event. And indeed, the event underneath, whatever you're looking at, it's not going to be precise. There is no precise thing underneath. You can't even say what the true air pressure inside the tire was. To Einstein, that was nonsense. He said, okay, we're not skilled enough, and he developed exactly as you said, an apparatus. It was a box, a hollow box with light flashing around inside of it. And when a clock ticked, a little hole opened in the box and some of the light went out. Well, light, you could measure how much that changes the weight of the box. So as something goes out, the box would go up in weight. At an exact moment, the box would go a certain amount up. You could see how much came out. This wasn't like the air pressure gauge. It happened without anybody touching it. Niels Bohr couldn't work out what was wrong with this. If this was correct, then you could have something happening on the micro level, but you could exactly measure without our interacting with it. There's a photograph of that night when Einstein thought of that. Einstein was always good with his hands. His dad was an electrical engineer contractor. Einstein had worked in a patent office, so he liked building things. When his sons were little, he would get a matchbox and string, and he was in Switzerland. He would make little ski lifts going up. He would make little cable cars just for the kids. He was good with his hands. So he imagined this wonderful box. And there's a photograph of Einstein and Niels Bohr walking down the street in Brussels, and Niels Bohr is really worried. But Einstein is smiling as could be. Aha. Sadly, it's the last photograph I've ever seen of Einstein looking really, really happy, because the next morning, Bohr, who is very, very smart, not a genius, but very, very smart, said, Einstein, when that box has a little bit of light go out, Einstein said, yes, exactly at the clock, which we're not touching, the box, if you weigh it, it goes up a little bit, right? It weighs a little bit less. Not a lot, but a little bit less. Einstein said, yeah. Niels Bohr said, well, when it goes up in the gravitational field of the Earth, and what happens then? And Einstein realized a problem. It turns out by relativity, Einstein's relativity, time is a little bit, it's not the same as air pressure, but think of air pressure. When you're on the surface of the Earth, air is quite dense. As you go higher up, the air is thinner. If you go to the top of Mount Everest, it's even thinner. Well, it turns out, for various reasons, time works at a certain speed on the surface of the Earth. As you go up higher, it changes its rate of advancement. And if you go up higher, it changes it even more. So as the box moves up, there's a certain uncertainty in the time. The time measurement is inexact because you're at a different point in the gravitational field. Einstein's theory of relativity made his idea not work. He had the good grace to say to Bohr, okay, in this case you're right. And that was the last time Einstein ever tried to fight back. But in his heart, he knew he was right. In his heart, sorry, that's wrong, that's biased. In his heart, he was convinced he was right. If you've ever argued about something you really feel strongly about, something very moral, say with a skilled lawyer, they might be more adept than you. They might do verbal twists and turns and jumps. They could win the argument, but you're convinced you're right. And that was Einstein. He knew it. It had to be.
And he was a self-aware person. I mean, he had a sense of humor about himself, and so he understood the irony that he was the young Turk who overthrew the old models, and now he, later in life, was in the same position of being the stodgy, recalcitrant, objector to the new wave of ideas that were coming along. Do you? And I was struck in your book at how open he was about the humor in that situation. So it's not as though he was blind to the situation that he was in. Why do you think he found it so difficult to give in, essentially, or to join with, to ally himself with people who were not overturning things that he had created, but simply pushing beyond what he had created?
I think the way Einstein viewed it was that he hadn't changed. He hadn't become, it wasn't that he was adventurous when he was young and became stodgy when he was older. From his perspective, something different had happened. He had been lucky enough to see one of these waiting truths. And this deep principle, the thing that had pulled him along in years and years of successful genius, was that there was an exact order and clarity in the universe. He felt that there was a long tradition of that. He didn't presume to say what it was, he just said it was there. His religious views tie in with this. Imagine a spectrum. Over here is extreme atheism, say Richard Dawkins. Over here is somebody who believes, say, literally in the New Testament and the Old Testament and some of the manifestations that they've developed historically. Well, Einstein was against atheism. He thought it was extremely unscientific to have that view. He said, how could you be so sure? Over here, he also didn't follow the details. For example, he thought that Moses was a very wise man, but he didn't believe that the Ten Commandments were given by God on Mount Sinai. But there's a big realm in between, and Einstein's views were much like his favorite philosopher, Spinoza, the Dutch Jewish philosopher of the 1600s. You can think of it as pantheism, that there's patterns in the universe which are significant. We don't understand what they are. We really are like a little child looking at a complex thing, but the complex thing is there. It's there and it's waiting. So Einstein felt he was in a tradition. Plato, Spinoza, to some extent David Hume, and himself. He had been able to apply his decent mind in mathematics. He was a B+ or an A- student, definitely not an A+, but he'd apply that plus his persistence. He used to say, I might not be smarter than others, but I have the persistence of a mule. So he'd really work on his stuff. And he felt that's what he had done. And it turns out, he felt, scientists had taken a wrong turn. They were going off on this stuff about this froth and probability and quantum mechanics, and he thought after a while they would return to the correct thing. And the reason that, the direct line that he'd had, and the reason he believed that is because it had actually happened before. For 10 years, all scientists had gone in a certain direction. He, to his great embarrassment, had gone with them. He had lacerated that great simple equation he'd had, and he'd found out there was a tributary. The truth had been what he had intuitively seen, this truth in a clear waiting thing. Well, that had taken 10 years. If Edwin Hubble in California had not made certain observations, maybe it would have taken 20 or 30 years. Anyway, so when quantum mechanics was coming in, Einstein thought, it's just a tributary. After a while, we'll come back to this mainstream of underlying truth, which I've been lucky enough to help reveal. It might not be 10 years, maybe it's 20 years, it might be longer than my lifespan, but it will come back. He felt that history would redeem him.
He thought that eventually the confusion or the randomness, the apparent randomness that was quantum mechanics would be just a sort of temporary error in perception, and that we would move beyond it to a deeper understanding of the forces. And do you think that's still possible?
Well, this is what's frustrating. When I was researching the book and when I wrote it, and perhaps when you read it, you sort of like, go, Albert, go, Albert, go. It's like, wouldn't it be wonderful if, like, just before he died or just after he was, like in the movie, somebody would say, look, we found quantum mechanics isn't true. And exactly as you said, Einstein and others thought, well, maybe there's hidden variables that, yes, things seem uncertain, but underneath, if we could just see better, we'd see a clarity. Unfortunately, in the 1950s, theoretical work, and then in the 1960s, certain experimental work, seemed to show that almost all notions of hidden variables cannot be true. And it does seem that quantum mechanics works really, really well. Our cell phones, our cameras, the internet, all depends on these strange fluctuations. They're not entirely random, but they're not predictable in the finest detail. It's kind of a shame that the universe is like that. It does seem different from what Einstein believed. It's also possible that even this effective technology that we have might be shown to be just an aspect of a deeper truth. This we won't know. When Einstein was young, when he was working on this general relativity, these beautiful ideas of this simple notion of time and space, he said that he used a lot of images. He said he felt that there was a lion out there, and he could touch the back of the lion, he could maybe touch the tail. He couldn't touch the whole thing. He couldn't even see the whole thing. Certainly in 1913, 1914, when he's coming up with his great ideas. But he said, I'm convinced it's there. He knew it was there waiting. So that was his belief.
Yeah. I was moved by the book when you talked about people in Einstein's orbit. There are a lot of people who contributed to his thinking. There are a lot of people who assisted him. There are people who may have been just a couple months or years behind him. If he hadn't been there, someone else would have gotten to relativity, for example. And then there's someone called Henrietta Leavitt, who
Right.
I was really interested in.
Wasn't that poignant?
Yeah. Do you want to talk about that a little bit?
Yeah. The word computer, we know what a computer is, but it turns out a bit over 100 years ago, actually 100 years ago, the word computer meant a woman who worked as computing things, calculating. And at the Harvard Observatory, Harvard had a real observatory in Arequipa in Peru, and it had its theoretical center outside of Boston, where Harvard is. And there were whole banks of computers, and these computers were women. And many of them were highly trained. This woman, Henrietta Leavitt, she had gone to what became Radcliffe, and she had A+. She was as good in mathematics as Einstein, in calculus and advanced calculus. She was a bright lady, but it was really hard for women to get jobs then. As you know, in England at that time, a woman couldn't set up a bank account in her own name. It just couldn't be done. So when she had all these great skills, she was employed as a dull computer in the back rooms at this laboratory outside of Cambridge. And the head of the lab then said something malicious. He said, well, they can't get any other jobs, can they? We can lower their pay rate. And so they had these highly trained women doing this dull stuff, calculating. They didn't have computers, of course, what are computers in those days, stuck in the back. Well, they usually say it takes two people to make you feel bad about yourself. The other person saying insulting things, and you to believe it. Henrietta Leavitt was a tough lady. She said, they could do that. It bounced off her. She said, okay, I'm stuck here. I'm in the wrong historical period. She was aware of the suffragette movement, that women could be stronger. There were many examples of women who were going to Europe, becoming doctors, becoming successful, some indeed successful in America. So she knew it was hard but not impossible. What are you going to do in a situation like that? Make the most of it. Don't just blend in and go with it. So she began to look at the new results coming in from Arequipa. And she noticed, so remember what I said, that most astronomers of the time believed that everything that existed was in our Milky Way galaxy, just stars floating there and nothing beyond. There were some clouds that we could see in the sky, especially in the southern hemisphere, the great Magellanic clouds discovered on Magellan's voyage in the 1500s. But people thought those were just little clouds amidst the stars. She started looking at them in more detail, and she saw that deep in those Magellanic clouds, there was something like a searchlight flashing. She began to study the rate at which that searchlight flashes, and it was really hard. She had to look at this photograph taken maybe May 3rd, 1894. So she had to work out, okay, the Earth moves like this. Find another one, maybe taken on May 5th, 1895, and try to compare them, get the exact location. And she would see she could use that beacon, that searchlight, going on and off at a very exact rate in the Magellanic Clouds to work out its distance. And when you have that, you can be able to see, is the distance changing? How about our other things? Maybe you can see that searchlight in other galaxies even more distant. It was a wonderful notion, and that was exactly what the famous Edwin Hubble used to detect, I can now see inside these other things. I can see where these searchlights are. I can tell how far away they are. If you know, for example, how bright a certain a searchlight is, and if you say, well, it's a certain brightness, you can tell if it's very dim, that means you're pretty far away. If it's really bright, that means you're on top of it. You've got to steer to the side without hitting it. They could use that. It became a yardstick to measure your way in the universe. It was a magnificent discovery.
So without Henrietta Leavitt, Hubble wouldn't have had the tools he needed to understand that the universe was expanding, and without Hubble, Einstein wouldn't have had the understanding of the universe that allowed him to decide he didn't need the cosmological constant after all. Is that pretty much?
That's exactly right. So the ironies go on and on and on. This woman who Einstein never met, if she hadn't done her work, Einstein, the astronomers might even today have thought, well, the universe is static. Kind of makes sense. It's a beautiful universe. Our Milky Way galaxy is exciting. There's stars, and you could find out planets. But people would think it was all that was it. It was just hovering kind of statically.
So I mean, part of me feels like, all right, so why do we have to call Einstein a genius? And I don't know what Hubble is, but there seems to be some kind of chain of contributions here that are all essential, and yet only Einstein is on posters in people's dorm room walls. Do we even need the term? How valuable is the term genius here? I mean, how useful is it when there are lots of different kinds of people who are making contributions that make the big synthesis possible?
That's a good point, because what makes them leap out? Einstein was, he actually was a modest man. He said, look, as I was saying, he knew his mind was good, but he knew many people had good minds. The reason he became famous, the reason he was picked out was not because of E = MC squared. That came in 1905 when he was 26, and when it was published, he stayed in the patent office for several years. It didn't even come because of his ideas about astronomy and the way that all of space can sag down and curve. That came in 1915 when he was in his mid-30s in Berlin, as I mentioned. He wasn't famous then. It turned out one of his ideas led to an amazing prediction. Can I go into that with the eclipse? Yeah. So this great idea that Einstein had in 1915 was that we think of space as totally flat. We think that space is kind of like, imagine there's a trampoline made of taut, rubbery surface and stuff. Or like you're in the United States Marine Corps and you have to make your bed really, really flat and taut, right? Suppose there's a trampoline, rubbery, flat surface, and that's what most people before Einstein thought outer space was like. If you take a ball bearing and flick it along, it'll just go along the surface. Wherever you flick it, it'll just go in straight lines. Kind of makes sense. The planets could just go in straight lines. But Einstein had a different vision. Suppose you take a rock or a small bowling ball and you put it in the middle of a trampoline. It'll sag down, right? And then you take a little ball bearing and you shoot it along. Well, it goes into that sag and it'll whip around in a curved angle, like hitting a ball inside a pool pocket or a billiards pocket in England, right? It'll curve. And Einstein had this idea that all of space can be sagged down if there's something heavy in there. Well, in our solar system, there's something very heavy, the sun. The sun is really heavy, and if Einstein was right, things would sag down around the sun. Invisible space would be as curved as the surface of our Earth. And remember the thing about if we were walking parallel on the curved surface of our Earth, strange things happen, we'd converge. Einstein thought, suppose there's a star far away behind our sun. Normally we couldn't see it. It would hit the sun and the light would never get through. But if there's these invisible curves around the sun, if the sun is really heavy and makes space itself sag down, just think of a rock on a trampoline sag down, then distant starlight could whip around the sun and we could see it in front. Now normally you can't see that because the glare of the sun is too bright. But suppose there's a solar eclipse. The sun is blocked out. You could see a distant starlight that whipped around and came into us. That image of the billiard ball, of the little ball bearings flicking along, you could actually see it. And he predicted this in 1915. He had a very clear prediction. Nobody, of course, could check it out because it was the middle of World War I. In 1919, a British expedition from Cambridge, England, led by a man named Eddington, sent teams off to Brazil, teams off to West Africa. They measured a solar eclipse, and they saw that distant stars whipped around in a curve exactly the way that Einstein said. This notion that space is curved sounds kind of weird when I say it. It's actually true. You actually see things whip around like that. This was an astonishing result. And
that was the real beginning of Einstein's worldwide fame, right? I mean, it was the results of that observation that really catapulted him into the headlines and made him an icon of modern science that we know.
Totally.
I love your anecdote about the New York Times correspondent who was sent to cover I'm not sure which event he was actually. Was he the announcement of the found, right? And they didn't have a dedicated science correspondent, so they sent their man in London to cover this thing. He was actually a golf correspondent.
Correct.
So he had a very, he sort of covered it the way you cover a sports event with a lot of excitement, a lot of hyperbole, but he more or less conveyed the right idea. And the headline. It was a Times, so that sort of string of Times headlines that they put on the front page about this discovery was really, really electrifying.
Yes, and it came right after this cataclysm of the First World War and the Spanish influenza. And what had happened was that these enemies, England and Germany, they had kill each other. Wave after wave of young men, sons, brothers, husbands, died, one after another. The countries hated each other. After the armistice in 1918, the British Navy put a terrible blockade on Germany that killed a vast number of people from starvation. They said, well, deserve it, look what they did. But yet, after all that hatred, an English astronomer took the ideas of a Swiss-German mathematician and physicist and used it not just on the ground in friendliness, that itself would have been nice. They used it to look up to the heavens. And the heavens were, think if you're a soldier sleeping on a winter's day. You look up at the clear, clear sky and you think, that's a realm of truth, of quiet. That's a realm where we don't kill each other. We're grown-up men who've maybe studied the same things and watched the same Charlie Chaplin movies, which were popular all over Europe. They wouldn't attack each other. We should have something in common. Remember Saint-Exupéry? Couldn't we look together in the same direction? Yet in the wartime, that didn't happen. The huge guns would boom. In 1919, though, people thought, wow, Einstein's mind had produced a unity. We could not only have friendship, we could see this deepest truth. There's a difference between a priest and a prophet. A priest is somebody who's down here on earth, opens a spigot, and divine force or extra information pours down. They sort of guide it. It's like a funnel or a channel. A prophet is very different. Einstein, after 1919, was seen as a prophet. A prophet goes up to another place. They look around in that place. They have experiences. And then, because they're kind and decent, they come back to us and they share it. You know those beautiful photographs of Martin Luther King when he was old? He's a noble man. He had seen something. He had actually looked into the promised land. And he came back to us to share it. Some photographs of Nelson Mandela have that same notion. And that's what happened with Einstein. That's what made him more famous than Leavitt, more famous than Bohr. His ideas were superb. Her ideas were very good also. But he played that special role.
Do you think that image of a kind of, a prophet-like seer, a genius in the Einstein mold belongs to the past? Do you think that the era when a single person working mostly alone could reconceptualize the whole universe could happen again today? I mean, I don't know a lot about theoretical physicists, but I picture them working in CERN and dealing with giant apparatus and working in enormous teams because that's the way the work has to be done today. Mm-hmm. Could there be another Einstein?
You never know. Whenever you think everything's predictable and about to stay the same, it'll swoop off to the side and change you. James Webb, the guy who ran the American Apollo project successfully in the 1960s, taking men to the moon with technology which is now inconceivable to us. Apollo 11 that went to the moon had 66K of random access memory, which is a little bit less than our phones. But think what genius it is to program everything you need in just 66K. James Webb said, and he knew a lot about making large things work, he said, it's what you didn't expect that'll destroy you. What you didn't expect, everything's working. Saturn V, maybe millions of working interrelated parts, all exploding and churning, but something you didn't expect is what's going to come in, and it's always around the corner. Well, the same thing happens in the history of ideas. The same thing happens actually in history. We're seeing it, God forbid, in the 2016 presidential elections. Something that nobody imagined possible could come in, and one has to be ready for it. So although it's unlikely that somebody could stand out in science the way Einstein did, when he was a student in Switzerland, there were about 6 physicists in Switzerland. Now there's hundreds or thousands. There's tens or hundreds of thousands around the world. It's harder to stand out. But the thing is, you never know, and that's what makes it exciting. There could be somebody in this room. There could be a 10-year-old in China or Malaysia or South Africa. We have no idea who might come in with a fresh angle, go into that library, take one of the books off the shelves, and say, look over here. Nobody thought of looking here.
Yeah. You told me before we started that you had spoken to a number of people who knew Einstein personally. What did you learn from them? What did you find out that you hadn't known before?
One of them was the Indian astrophysicist Chandrasekhar. Again, when I was young, he was old. He was one of the men who taught me at Chicago. He was the first person to come up with the notion of black holes. One of the things that came out was how funny Einstein was. We think of this great sage and seer, like that. Yeah, think of it as somebody with a German-Jewish sense of humor. And that actually helped him. It wasn't just a little affectation or pleasantness on top. It actually helped him. When he was, I'll give an example. When he was a little boy, when he was about 7, he had a little sister named Maja, and he was upset one afternoon. He took a bowling ball and he threw it at her, and it must have been made of rubber. It hit her in the head. And she wrote, she said, and that shows it takes a thick skull to be the sister of a world-famous physicist. And that sort of sense of humor, that ability to step back and tease what's going on, is exactly what he did in physics. Everybody had the notion that outer space is flat, right? You flick a ball bearing along, or you flick a planet along, it's going to go in straight lines. But he saw this, he could imagine this curving sag. He could think, how could two parallel people converge? Little clever. Step back. Imagine it not being on a flat surface. Imagine it being on a curved Earth. Maybe there's deeper curves we can't see in outer space. It's that ability to step back. So that humor, that's what Chandra remarked on. Einstein's sister wrote a little bit later, when Einstein was in a secondary school in Munich. His teacher of Greek, a man named Dagenhart, said, Einstein, you'll never amount to anything. And his sister wrote, and indeed my brother never did teach Greek at high school in Germany. And I love that. If somebody criticizes you, again like Henrietta Leavitt, you could take it to heart and say, oh, I have to give up, I must be unworthy. Or you could say, yeah, whatever, and just switch around and see it from a higher perspective.
David, could you talk a little bit about Einstein's personal life, especially? I found his first wife really fascinating because she was quite a brilliant woman and was a kind of collaborator with him early in their marriage. And
there was a great poignancy. We think of Einstein as this funny old man with long hair. When he was young, he was hot. He was really good looking. Even into middle age, people remarked that when he would take his shirt off, he was a sailor all the time. He was a fit guy. And so he was young, he was good looking, and he was in a class of 6 or 7 students at the Polytechnic in Zurich. There were many Jewish people in the class because Jews at that time weren't allowed to go into experimental physics in Germany. Experimental physics was high prestige. You can get good jobs of it. People thought that was important. And the Jews, they weren't hated in Germany, but in Switzerland, but they were just mildly discriminated against. And they were pushed aside into what was considered the trivial or ridiculous fields of theoretical physics. So many of the people in his class were theoretical physicists. And they were all guys, and they were perfectly nice. He made longtime friends with some of them. But one of them was this hot young woman from Serbia, Mileva Maric. And she had crossed Europe on her own and learned good enough German and to be a science student in Zurich. Even today, that'd be impressive. In the 1890s, it was terrific. And Einstein told his friends, her. And he courted her. He courted her in a very curious way. He would speak to her about advanced calculus. And he spoke to her about his dreams. He said, well, we could live together. We could be like Marie and Pierre Curie. We could do science together. We'd have a bohemian love and friendship. We'd be like students forever. And I can give you a special gift. This gift has been recorded in the Einstein archives. And she wondered what that gift would be. Would it be love poetry? Would it maybe be a recipe that his mother had made for him that she could make to show that she could take over that role? He was a Jewish boy after all. Instead, he drew something and gave it to her, and she looked at it. It was his foot. He had drawn an outline of his foot so that she could knit socks for him, so he'd have nice, warm feet. Their relationship at the beginning was beautiful. The night after he the night after he finished writing the E = MC² equation, a postcard survives. There's a postcard that Einstein wrote to one of his good friends, Konrad Habicht, and it says, both of us, alas, Mileva and I, dead drunk under the table. And he signed it, and she signed it. So they had a good time. Unfortunately, when they had children, there was, I don't want to call it sexism. Sexism suggests that somebody's being mean, that they're being unfair and choosing willfully to do something bad. In 1905, 1906, things were different in Switzerland. It was assumed that the woman takes care of a child. Einstein was really friendly. As I mentioned, he would make cable cars for his kids. He'd play the violin.
He would get down on the carpet with toddlers, and he was a very doting parent.
Correct. He was hands-on, but still it's sort of the way that a man gets huge credit. Look, he played with a child for 3 hours on Saturday. And the wife says, yeah, right, the rest of the week. So he was good, but she had to do all the stuff. And she had been an okay student, so if Einstein was a B-plus student, she was like a solid C or C-plus student. She wasn't great, but she was able to do theoretical physics at a pretty good university. But she didn't have time to follow up. She had to change the diapers, she had to get the feed, she had to take care of, they had 2 kids, they had a girl first who they gave up for adoption, and they had 2 boys. And after a while, people would come to the house originally to talk to both of them, but after a while, she was so busy. They would come in, and you know what it's like, you want to join the conversation, but the kid's crying. So you go and take care of the kids for 20 minutes, and then you come back, conversations moved on, and after a while, she stopped coming in. Their oldest friends, the ones they'd all been students together, they'd been 18, 19, 20 together, with them she would still be connected and fun and full of life. But the newer friends, after a while, would come to see here Professor Einstein, and her was just this woman off to the side. And that hurt her feelings, and their relationships slid apart. They became nasty to each other. They became cold. Occasionally, she wrote beckoning letters saying, you remember me, don't you? And remember what we hoped for? And it just fell apart. And by 1914, they moved to Berlin trying to save it. It stopped. He started having affairs, which wasn't that nice while he was still married, with one woman in particular, a woman he married on the rebound. And she was the opposite of the first one. She wasn't that sensual, and she wasn't that intellectual, and it was a dull marriage.
She was his cousin.
Yeah, second cousin.
Yeah.
And at that time, in England, that would be like weird, but in Spain and Germany, that was considered acceptable. And they hadn't. The problem wasn't even that they shared a culture. The problem was she was very bourgeois and very proper, and he thought she'd be interesting. As he once said to his son, he said, "Elsa is no brain box," he said, which was kind of mean because she wasn't doing anything wrong. Later, he realized that she was a good person, and they actually became friends. They shared a certain sense of humor, but in between, he started having affairs, especially in the 19-teens and 1920s, especially in the 1920s. And he was very decent, if you ever can be decent about affairs. He didn't flaunt the affairs in front of his wife. He had a separate weekend cottage, and his housekeeper was interviewed later. And she said, the professor was always so charming with those lovely women who came over. There was always conversation and laughter and guests for dinner. He found it more fulfilling, but it wasn't enough. His best friend was a man named Michele Besso, and they met as students, and they had that camaraderie you can, I think, only get when you meet as young adults. And they stayed friends for 50 years. And Michele Besso died when Einstein was in his 70s. And I went to Besso's family and said, "You know what I liked about your father? I admired his intelligence, I loved his kindness to me, our friendship. But what I most admired, he spent 50 years, he spent his whole life with one woman, something which I sadly have been failed at twice. It meant a lot to him to be close. He yearned for connection. He found it with the universe. He briefly found it with affairs. He found it for maybe 4 or 5 good years with his first wife. But in his heart, he didn't really find it."
And he had a pretty good relationship with one of his sons, especially later in life. Is
Yes.
that right? Because he came to America after the war and settled in North Carolina or South Carolina. This is Einstein's youngest son or older son?
This was Einstein had 2 sons, and his older son was named Hans Albert, who was often called Albert, just to make it confusing in the handwritten letters. And he spent a while in North Carolina, and then he became a professor of hydraulic engineering in Berkeley. When Hans Albert actually was an old man, long after Einstein had died, somebody said to him, "Did it bother you having Einstein as a father?" Hans Albert looked at him and said, "What do you mean? My father was Einstein. Who's going to compete with Einstein?" It's fine.
Yeah. Well, this is wonderful. I think maybe we should take a few questions if people have them, or if there's other things you'd like us to discuss.
Great. When the lights go up and we can see you, we'll take questions, and we've got microphones on either side of the house. And of course, we can only in this context take either genius or intelligent questions. So prepare yourselves very well for that. But anybody want to give a crack at it? Yes, right at the back. Thank you.
I'm about to display my vast ignorance. Did you say that Einstein came up with the theory of entanglement? And that's not part of quantum physics?
Yes, in 1935, Einstein was still occasionally trying to disprove quantum mechanics. And at one point, he realized, with his great mind, that if quantum mechanics is true, objects that are widely separated on opposite parts of the galaxy, of the universe, can still have a certain strange synchrony they can have a synchronization. He thought that made no sense. He said, "Puh, if quantum mechanics is true, separated particles can be entangled and interrelate instantaneously. How preposterous is that?" Well, it wasn't preposterous. This is what's been found to actually be true, unless our quantum computers work that way. Even the extreme, not sarcasm, but when he tries to disprove something, a genius is still pretty good.
Great, thank you so much. Anybody else want to try? So, while they're preparing for their genius questions, I'll try a very, very low-minded one of my own. So when you mention the greatest mistakes that you introduced the conversation with, and David Orban, in your play, what was the father's sort of greatest mistake? How would you characterize that? And does that compare in any way with Einstein's?
Well,
you might want to contextualize it a little bit for...
Sure. If you haven't seen the play, it's basically about the daughter of a mathematician. Mm-hmm. She is also a mathematician, as it turns out. And the play begins a couple of days after her father has died. She's aware that he suffered from mental illness for many years. She spent a lot of time caring for him. And now, knowing that she has some talent, she's also worried that she may be inheriting his mental illness. So the play kind of takes place in the few days following her father's death. And I think in a way the play trades on a commonplace about scientists and mathematicians that comes partially from Einstein, which is that miraculous work is done in the youth of the person, and that as time goes on, it's harder and harder to stay on the cutting edge. It's harder and harder to innovate, and the new discoveries belong to the next generation. So I think in the play, the sort of emotional climax comes when the father, after many years of struggle and frustration and illness, believes that he has once again kind of gotten a glimpse of his miraculous talent that he had as a youth, and that turns out to be an illusion. But the euphoria of that moment and then the pain that follows when he realizes it's not true, I guess you could say is sort of his biggest mistake that we see in the play.
Mm-hmm.
Yeah.
Thank you.
Can I ask, if your background was in other fields, do you feel that either something that you've experienced or things that you noticed, that translates into other realms of action? So you described it beautifully in math, and I've seen that from the inside. Have you found it holds for people in their professional lives or their personal lives, that desire, that feeling, I've done it again. I've had that magic, that fire from what I had before, and hoping for it too much and then disillusion?
Yeah, very much so. I mean, when I've heard scientists talk about their greatest moments of discovery, it's in exactly the same terms that artists use. It's in exactly the same terms that people talk about when they talk about falling in love. It can be sexual. I mean, that all of those euphoric experiences seem to sort of occupy the same emotional key across all different kinds of human endeavor. I found that really moving. I saw a film once, a documentary film about Andrew Wiley, who solved Fermat, and at the very beginning of the movie, the first thing you saw was him talking about, he'd spent years working on this problem, literally years. And I think at the end of a particularly intense period of, months of locking himself in a room simply to work on this one problem, he felt that he had cracked it. And he looked in the documentary film camera, and this very reserved, very soft-spoken, quiet man started talking about the moment when he felt that he saw the solution, and he burst into tears on film. And it was, you could see that the power of that emotional moment was still present for him every moment. So yes, certainly one of the impulses for the play came out of that feeling of wanting to convey that those the power of those emotions can come in any kind of work. Really.
Mm-hmm. Can I do a follow-up for that?
Yeah, sure.
Yeah. So one thing I've been struck by, there's a story that is told about many film directors, many movie directors. I'll apply it to Steven Spielberg. Somebody says to Steven Spielberg, why do you always make the same movie over and over again? Spielberg's movies are always about innocence under attack. It could be a shark attacking a seaside town. It could be a 2,000-year-old alien being attacked by a decent one being attacked by the FBI or security services. Over and over again, innocence under attack. It resonates with his childhood. It's his theme. John Ford had his own themes. And Spielberg, apocrypha, would say, well, it's a very good movie, right? And in science, if you repeat the same thing, it's no good. You've actually done exactly the same thing. But sometimes people in art, music, I know more than the theater, they'll approach something and they keep on doing it. And as piece after piece, as the years go on, and it can stay beautiful. Maybe once or twice in their life, they'll shift to another thing. But the fact of doing it over and over, there's extra richness or angles. Have you found that theme in proof that you described, has that meant a lot to you, and are you still struck by that theme, or have you left it in some way and there's other themes that you want to approach over and over?
It's not that theme that recurs, but I do definitely feel certain things that are resonant, and I'm not always aware of it at the time. I've written 3 plays since Proof, and the only thing I think they have in common, and I only realized it fairly recently, was that they all have scenes of a young woman comforting an older man in distress at one point or another in different formulations. That sort of parent-child, the dependency of a parent on a child, and the complications that arise out of that. And I think that the longer I do this, the more I feel that the real challenge for anyone, any artist, or really anyone, is that you have certain material or certain core experiences that resonate for
yes.
you. The way a tuning fork resonates. When you strike them, the vibrations come and interesting things happen. And the challenge as you go on in your career is to kind of keep trying to push away from those things that come easily or naturally to you, and to keep expanding your comfort zone in a way, to keep pushing against the edges of the things that seem easy to you emotionally or artistically, without losing contact with that somehow. That striking that balance I find challenging and interesting, and it's the constant struggle.
That central image that you described, you may not have realized it when you were first writing it, but looking back, oh yes, it's there again. When you say push away from it, is that ignore it, or is that like take that and place it in different domains?
You want to pretend that you're ignoring it. I think you want to the minute you become too conscious of something, that then it becomes a cliche or a trope that you're just returning to because it's easy.
Right.
Quite how one manages the mental gymnastics of that every day when you sit down at the desk is something I have no real insight into.
There's a beautiful line from Carl Jung. He said that we often, women he thought mostly, but men also, we often try to fulfill the unfulfilled dreams of our parents. Not the things that they've done, but the things that we realize they yearned for and were unable to do. My mother would have liked, if matters had been different, to have been a doctor, but she grew up on a farm. They were poor. She was unable to be a doctor. I didn't realize why, but the first book I wrote, I was just drawn to, was about the human body. I knew it was an interest she had. We never spoke about it, what I would write about, but I felt, yes, I was trying to fulfill this unfulfilled dream. So that trope that you mentioned about, that you saw in several things, do you think there was something that, looking back on it, was something you wished had been able, either for you or a previous generation, to do in your family?
Yes, very much so. And if I were paying you, $475 for every 50 minutes, I would go into that very deeply. But
we have 30 minutes.
Yeah.
And,
no,
right.
but absolutely, no, it's absolutely the case. And I think that that what's interesting about writing is that you don't know that when you're doing it.
Correct,
You know,
correct.
you figure it out, if at all, only after the fact.
Certainly one thing, popular science writing is very different from this, but I've written in some other areas. I've written history, and I recently wrote a novel and stuff. And it's tempting, especially when you begin writing. The first stuff I wrote in my early mid-20s is excruciatingly embarrassing. It was just mediocre. It wasn't even bad. If it had been bad, I could be humiliated. It was just like, dull. It was no good. And the problem is that all that heart, those tropes, which we would talk about for 475, that's a lot in Manhattan, that we could talk about.
Oh shoot, I've been paying too much.
I wasn't doing that. I was trying to match the surface of something. You see the humor style of somebody, or you see the dead serious style of somebody, and if you're young and have some skills, you're a mimic. You try to copy it, but the heart isn't there. It's the sort of like there's a few sequels that are very, very good. Godfather Part 2 is a good sequel. They reimagined, they developed a fresh story. But as you know, most sequels are mediocre, and they hit all the key points. Think of Bridget Jones Part 2. They touch all, exactly, but they did all the right things. Goofy best friend? Check. Fight between the two guys? Check. You know, boom, 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 boom. But the heart isn't there. Have you found that when you teach theater or talk about it with students, that is it hard to get them to say, yes, you need these technical skills, but you need the heart? Or do they know that? Are they driven by it, and they're frustrated that they lack the technical skills?
It's both, but I think it's a challenge for anyone, students or people who have done it for a long time, to figure out how to probe into the stuff that really bothers you, which is where good plays and I think good novels end up coming from. You know, the things that keep you up awake at night, the things that trouble you, the things that just are under your skin and just and that you keep itching away at. Those are the things that, if you can find a way to transform them, to fictionalize them, or to use them, that's the clay that you kind of need to excavate, and that's never that easy. You know?
What I envy about playwrights is that you can have those things, and if you're good, you manage to excavate it. Not being aware, it's hard, but somehow you manage to excavate it. And then you can transmit it through this complex vehicle of the actors and directors and lighting and all that sort of stuff, and then the audience can get it. So what the feeling you had, they can get that feeling, and it can transmit across. Einstein had certain feelings, those visions that I mentioned of the universe as like a book, the visions, all those things I talked about, the curves, the sags in space, the books waiting there. But the actual stuff he did, the stuff inside his head, is technical, and most people can't share it. It would be like if you speak a certain language and you go into a different culture or a different language zone, and there's attitudes that you want to bring across, and you just can't. They won't get it. So I think many of those people feel frustrated. Sometimes when one talks about nerdy scientists without emotions, they have emotions very much, but they can't communicate it in ordinary language.
I thought that you did convey, in a very visceral way, some of Einstein's ideas, which is one of the real wonderful things about the book. Particularly your description of the elevator that's falling, and it's either falling or it's in space. And I'll let people read it because I can't summarize it well, but you do a beautiful job of giving us a gut feeling of the sense that Einstein might have had when he first glimpsed these deep connections among what seemingly disparate phenomena.
That was very much the goal. Oh,
yeah.
Do you have another question?
Yes, question.
Yeah. First, I loved this lecture. This was so inspiring. I can barely sit in my seat. It was so exciting. I was married to a physicist for 40 years. But I wanted to just make a couple of statements, and maybe you can speak to them. Do you think that genius can exist without the presence of intuition? Einstein talked about the speed of light, that was a constant. Nothing traveled faster than that, but then they discovered tachyons. Is there a sense of, at the speed of light, if you're on a train and the light that's at the head of the train, if I'm traveling at the speed of light, would that light be seen? And all these things these magical imageries that come, even when you're talking about technical stuff, for me, it's like a movie that comes in my head, and I don't know anything about formulas. So do you think that genius is sans intuition, and how do you put that together with wisdom? Is wisdom the application of that insight and knowledge? And I do believe in the room of the books. I do believe that when you are fully focused on something, you are sitting in your genius, and that creativity comes. But how do you marry intuition with genius?
Some people consider genius a process, and wisdom is the end result. So genius can be like a mechanism, like an elevator or a railroad or a jet or whatever, taking you to a place in which wisdom exists. Is that how things work for you?
I don't know. I mean, I think I feel increasingly uncomfortable with the term genius. I mean, I'm not quite sure what it gets you in a lot of ways. I'm not sure. I mean, clearly there are people like Einstein who changed the whole category. I was trying to think of an analog in theater, and I think probably the best one in the 20th century would be Beckett.
Correct.
Beckett, other people have written extraordinary plays. Long Day's Journey Tonight is an incredible play, but after Beckett, no one could write the same kind of plays that people wrote before Beckett, in a way. So, and that seems to be a good good analog with Einstein. But other than the few of those people who truly kind of are category shifters, I don't know if talking a whole lot about genius does anything except make other people feel bad. You know what I mean?
There's a lot of that.
Do you think genius comes in the space of where something is introduced for the first time? Like if it's never been known before or seen before, it appears to be genius, and then it really is just gets co-opted into everyday problems? Do you think that that's something that happens?
New things can be brought to our attention in two different ways. Sometimes we're lucky enough to have new technologies. The first man who developed the microscope, von Leeuwenhoek in the Low Countries and to some extent Hooke in England, they had a magnificent ability. Instantly, with ordinary skills, an ordinary person could see things that nobody else had. And they produced wonderful insights. And in the history of technology, we have that a lot. The moment you have certain electron microscopes, you can discover DNA, or X-ray crystallography. The tools can do a lot. So that's one sort, when you're helped by a tool. Another sort of fresh insight comes through just thinking, just coming in from an unusual, fresh angle. Beckett didn't have different actors. He didn't have, he was skilled at languages, but many people are skilled at languages. He was Beckett. He was really good. And then in science, there's the added thing. It has to match the real world. So that's why Einstein's approach worked really well, but his final one didn't match the real world.
Yes, we'll take that in a second.
Fresh question, but what you mentioned that they gave up their first child for adoption. Could you go into that a drop? Because
sure.
What was the reason and what happened?
So Einstein's family was living in Italy. They had left the south of Germany when he was 15 years old. A little bit, again, not extreme anti-Semitism, but moderate anti-Semitism. His father was an electrical contractor, and he found that time after time in the city of Munich, his contracts were rejected by the municipal administration, even when a private industry would build this stuff and his things were fine. So they decided to try to make their mark in Italy. Einstein dropped out of high school when he was 15, moved to Italy, left Italy, blah, blah, blah. So the family was in Italy. Einstein was in Switzerland, and that's when he met beautiful Mileva. And he decided to go on a holiday with her after they'd been together for a few years, and she had knitted him those lovely, cozy socks. It turns out, footnote, Einstein once applied to be in the Swiss Army, and he was rejected, a little bit because he had flat feet, and also because he had unusually sweaty feet. He needed those socks on the cold winter nights. Anyways, they went on a holiday in the snows above Lake Como, and they were in a sled. And they held each other, as she said, very closely. 9 months later, she gave birth. They weren't married. And at that time, in middle-class families, you just couldn't raise a child if you weren't married. And you couldn't, maybe a child could be born a month early, it couldn't be born terribly early. Einstein's mother had rejected Mileva marriage, largely because she'd reject anyone who was dared to marry or touch her son. I think the Talmud says that when a Jewish man gets married, he divorces his mother, but often the divorce is contested. So Mileva, when she was pregnant, went back to her family in Budapest, and they couldn't raise the child. I think this was probably a great part of her later sadness. They seem to have done, the child was named Elizabeth, Eliserel in German slang, and they tried to do the best they could for the child. It seems they put her up for adoption and actually gave her to Mileva's, one of her best friends, who was married and living outside of Budapest, which, if you think about it, is a sort of a fair compromise. Nobody knows what happened to the child after that. I believe there's been novels imagining it. She went back to Switzerland, they got married, they had these 2 other children. Einstein delighted in that daughter that he never saw. A letter survives where he said, "She's born, Mileva, tell me all about her. Does she have beautiful eyes like yours? I'm delighted and I've never seen her." But then they stopped referring to her in the letters, possibly because it was too painful. When you're busy and things are going well, sometimes a sadness in your past, you can forget about it. But when you start getting another sadness in your life, all this resonates and comes back to you. So I think as their relationship fell apart, she must have dwelled and wondered, the child would be 6 years old now, the child would be 10 years old now. Something's wrong with me as a mother. Not that I blame Albert, but I'm associating him with this terrible desolation.
Thank you. Maybe we can take one last question if you have one, and otherwise, yes, here, thank you.
Do you think if Einstein was alive today, would he have a change of heart about quantum mechanics, given how far it's come in the real world and the way we see it in everyday life? Or would he hold to his sense that there might be some holistic notion that the universe is kind of is precise and is kind of, as you mentioned, the wave and so forth and so on?
It's very hard to tell. If he came of age today, it could be his whole personality would be different. When IQ was begun in France, it was begun by Binet and other people in the French, in the slums actually in Paris. And people thought that IQ was like muscular strength. You could measure people's IQ, and you would find people with low IQ, and you'd give them exercises, like taking undernourished slum children, giving them good food and exercise, and they become stronger. And Binet found that repeatedly he could raise children's IQ very substantially, 1 or 2 standard deviations. That notion moved to America, which was much more of a Calvinist country, and Binet was startled that it changed. The notion became in America that IQ was something fixed forever. If you had it, you had this capacity and it could never change. There's something to that. Clearly some people are quicker witted than others, and it seems intrinsic. You can see it in little kids. But there's a great variability. So if Einstein was born in any other family, he wouldn't necessarily have gotten that sort of humor with his sister, the bowling ball and stuff. And imagine if he hadn't had the sort of training he had at university, the ability to step out, and he failed his first exams, or even working in the patent office for a few years. He really got his hands on. Einstein once said that if he had gone straight back to academia, if he'd been a grad student and become a junior professor, his career wouldn't have worked. He would have had the same intelligence, and then even the same humor, the same training, but he would have had to have published every 6 months. He wouldn't have had time to just leave the city and just think for a while. The great Rabbi Hillel once said that if you have a burning fire and lots of sticks and they're burning, if you take one of the sticks away, it'll flare up brighter than ever as the fresh air hits it. If you hold it away for too long, however, it'll become just a dark husk. It needs the community. Einstein's career was a perfect illustration of Hillel. He was trained well in science, and he had this nice attitude. Then he was taken away from the academic world for 6 or 7 years in a patent office, which was perfect for flaring up bright. But before he died out and became cranky and isolated, his ideas were beginning to be accepted, and he was brought back into the university system. If he was around today, that particular path quite likely wouldn't have happened. And if it had not happened, maybe he wouldn't have been Einstein.
David Bodanis, you recognize that Einstein was not the best mathematician in the world, but what you did recognize was that he had this vibrant visual imagination and could see things that others couldn't necessarily see in their correlation. And we've been talking in the context of wisdom, and I suppose it's my duty to connect those two together, because in the wisdom tradition of Tibetan Buddhism, you are really entrusted with the tools to exercise a visual imagination, and you can see those in the mandalas upstairs, that your role is really, if you want to transfigure yourself, you imagine yourself as the emanation, the deity in the center of the mandala, and transpose yourself into that being as you imagine them to be. And by that, you actually discover, realize the wisdom that's within. So the painting is like a guru, a remover of shadows that reveals the light within. And so that's just the connection I think I'd like to make and leave us with, because up until 9 p.m., of course, you'll have bought a book and hugged it closely to yourself, but you can also go into the galleries and explore for yourselves and see what is revealed to you with that exploration. But David Bodanis and David Alban, thank you so much. Thank you. Thank you. It was great. It was really good. Good stuff. Comes in the form of a presentation of a silk scarf that in the Tibetan Himalayas is presented to those people we wish to honor. And it's not like a Pulitzer, David, but it's the only thing we have. So thank you so much.
Thank
Congratulations.
You very much.
Thanks for joining us. Thank you.
Thank you.
I have a sneaking suspicion, David Bodanis, that, oh gosh, he's going down on bended knee, in front of C-SPAN, no less, that might mean you're almost praying, which is that I think that this book is very likely not to be translated into 28, but many more languages, because you've made Einstein's life and his extraordinary contributions so very effective and approachable and understandable to us. So thank you so much for that contribution. Thank you. Thank you. Thank you very much. So join us upstairs if you will, and wish you a good night and learn something else.